All right, numbers 2 through 6 ask us to find each limit algebraically. So let's look at the first one. We're asked for the limit as x approaches 2 of this function, x squared plus 4 over x plus 2. First step is always going to be attempt to plug in, because we don't know if we need to do anything more until we've tried to plug it in. So my first step, I'm going to plug in 2. 2 squared is 4 plus 4 over 2 plus 2. This is 8 over 4, which is just 2. There's no problem with this answer. There's no dividing by 0. There's no ambiguity. It just has to be 2. So that was a straight, simple one. All right, question number 3 asks us the limit as x approaches infinity. So here we cannot plug in infinity. It doesn't really make sense to plug in infinity. But we have to imagine what's going on at the ends of the graph. That's what the infinity is asking us to do. So we had 3 rules for horizontal asymptotes, because if a function has a horizontal asymptote, then that really describes its end behavior at infinity. Another way to think about this is we're taking the numerator of the function and we're taking the denominator of the function and deciding what has the biggest play, what determines where that function goes. So if we take that strategy, basically for our end behavior model, right, we're going to take x squared from the numerator and x from the denominator, because they do a lot more than this 4 and this 2. Which tells us that our end behavior model is really y equals x. So out at infinity, this function begins to look like y equals x. Now we can kind of plug in, not really plug in a literal sense, but more in a kind of an abstract sense. What's going on at infinity? If y equals infinity, this function is going towards infinity. All right, number 4. First step we're going to try is going to be that plug-in method. So first step, we're going to plug in our negative 2. We've got negative 2 squared plus 8 over negative 2 plus 2. Negative 2 squared is 4, and 4 plus 8 is 12 over 0. This should be a red flag to you right away. We cannot evaluate anything that is divided by 0 until we have attempted to simplify further. So what can we do here? Well, we can factor. So the limit as x approaches negative 2 of x squared plus 8 over x plus 2. And I believe that is actually supposed to be x cubed plus 8. Let me just kind of fix that right here. X cubed plus 8. All right. With my little change, if it is in fact x cubed plus 8, we can factor this. It's a sum of 2 cubes. And that's going to allow us to SOAP it. Remember our little acronym SOAP? We're going to use our x and our 2. And we're going to determine the signs that go in the middle of them using SOAP. So S refers to same, the same sign that we saw there, plus. O refers to opposite, so the opposite symbol is minus. And that last one is always positive. All over x plus 2. Now we can cancel. All right, so we have attempted to plug in, it didn't work. We have simplified it algebraically. And from then, we are going to try with our new function just being x squared minus 2x plus 4. We're going to try to evaluate this at negative 2 by just plugging in. And this would be negative 2 squared, which is 4, minus 2 times negative 2, which is plus 4, plus that last 4, and that just equals 12. So the limit of this function as we approach negative 2 is in fact 12. All right, next color, and therefore problem. Let's try pink. All All right, this one, we're asking the limit as x approaches 0 of x plus sine x over 0. So we can't just plug in 0, because if we plug in 0, we're going to have 0 in the denominator. So step 1, that failed. All right, how are we going to simplify this? Well, it's a fraction. There are 2 terms in the numerator, and there's 1 term in the denominator. So we can actually split this fraction into 2 and rewrite this as the limit as x approaches 0 of x over x plus sine x over x. Normally we're combining fractions. This is where we're kind of separating fractions. All right, x divided by x is just 1. All right, so going one more step, we also should recognize that we have previously learned that the limit as x approaches 0 of sine of a function of a number over that exact same number, x over x, is equal to 1 based on the graph. The graph that we had learned a long time ago looked like this. And so, in doing this, if I take the limit as x approaches 0 of 1, I get 1. The limit as x approaches 0 of sine x over x is 1, and therefore this answer is just 2. All right, next one. All right. The limit as x approaches negative 2 of x squared minus 8 over x plus 2. All right, so looking at this, our first step, once again, is going to be to plug in. You can see if I plug this negative 2 in for x, we're going to have a 0 in the denominator, which means we need to try to simplify it algebraically. Looking at this, x squared minus 8 is not simplifiable. It's not. If it was x squared minus 4, it would be a difference of squares, and I could factor it. If it was x cubed minus 8, I could SOAP it. I could factor it as well. But there's actually nothing I can do here. If that happens, if step 1 fails, step 2 fails, we move on to step 3, which is where we accept that infinity, negative infinity, and dne, one of those is going to be our answers. So we have to decide which one it is. And this is when we look at the limit as x approaches negative 2 from the right, and the limit as x approaches negative 2 from the left. And we determine whether or not we're getting positive or negative values. We're doing this because we know that now, when x equals negative 2, the graph doesn't have a hole, it has an asymptote, a vertical asymptote. All right, so let's plug in negative 2. If I plug, a number to the right of negative 2. So something a little bit more than negative 2, like negative 2.1. If I square negative 2.1, I'm going to get 4 point something. And if I get 4 point something minus 8, I am still going to have a negative in that numerator, because this number will be less than 8. All right, if I plug negative 2 into the denominator, a number a little bit more than negative 2 in the denominator, I am going to have negative 2.1 plus 2. And if I have negative 2.1 plus 2, that is going to give me a negative also. So as we approach negative 2 from the right, we will get positive infinity. All right, guys, a little bit of a back step. I thought that was a little strange when I was looking at it. And in fact, negative 2.1 is a completely valid number, except negative 2.1, if this is negative 2, negative 2.1 is actually to the left of it. So this is as we approach negative 2 from the left. We get positive infinity. All right, let's approach negative 2 from the right and see what we get. Negative 2 from the right would be like plugging in a number like negative 1.9. So let's plug in negative 1.9 and see what we get there. If I take negative 1.9 and I square it, I'm going to get a positive number, and that number will be less than 4, because 2 squared would be 4, and negative 2 squared would be 4, but our number is going to be less than that. So 4 minus 8 is still going to give us a negative in that numerator. All right, let's plug in negative 1.9 into the bottom. Negative 1.9 plus 2. That's actually, negative number will be less than the positive number, so that will be positive, which will give us negative infinity. All right, so looking at this, from the left, I get infinity. From the right, I get negative infinity. So in general, those do not agree, and so the limit as x approaches negative 2 of this function does not exist.